want to write an expression involving rational exponents using lots of radicals, that's easy. We just go through one factor at a time. However, if we want to write an expression involving rational exponents as a single radical, that gets tricky. Let's see how we go about it. Let's suppose we want to write 3x to the 1/2, y to the 1/6, z to the 2/3 as a single radical. What does that mean? Our goal is to say some root of 3 to some power, x to some power, y to some power, z to some power is equal to this expression, where all of these numbers are integers. So in order to do that, in order to get all of these powers to be integers, I think I'm going to need to get a common denominator. So my first move is to find the least common denominator of the exponents. So my denominators, 3 is just 3 to the first power. So I have a 1, a 2, a 6, and a 3. I think the least common multiple of these four numbers is 6. And now I want to write each exponent with this denominator. Let's see. So my exponents are 1, 1/2, 1/6, and 2/3. Certainly 1 is 6 over 6. 1/2, well, I need to multiply 2 by 3 to get 6. So I need to multiply 1 by 3. 1/6 just stays 1/6. I need to multiply 3 by 2 to get 6. So I need to multiply 2 by 2. Alright, now I'm ready to actually address my expression. I'm going to rewrite my expression with the new exponents. My original expression becomes 3 to the power 6/6, x to the power 3/6, y to the power 1/6, z to the power 4/6. And now what am I going to do? I'm going to use the power of a power rule to pull out, in this case, 1/6. So I'm going to have big parentheses to the 1/6 power. The exponent on 3 is 1/6 times 6, so I'll be left with 3 to the 6th. The exponent on x is 3 times 1/6, so I'll have x to the 3rd. On y, it's just y to the 1/6 by itself, so I'll have y to the 1st. And I like to write in the first power in these circumstances, so I know I didn't forget. And then z to the 4/6 is z to the 4 times 1/6. And now we're pretty much done. We're going to write it as a radical, and we're also going to actually compute things with numbers, namely 3 to the 6th. We'll have the 6th root, 3 to the 6th, x to the 3rd, y to the 1, z to the 4th, and that'll be 3 to the 6th is 729. So that'll be the 6th root, 729, x cubed, y, z to the 4th. And we're finished. I'm going to give you one of these to try as well. Write the expression 2 to the 1/3, x to the 2/5, y to the 4/3 as a single radical. Pause the video and try this now. Alright, so I'm going to find my LCD. My denominators are 3 and 5. So my LCD must be 15. Right, 3 and 5 are primes. What can you do? So I'll have my 1/3. I had to multiply 3 by 5, so I'll have 5/15. 2/5. I had to multiply 5 by 3, so I'll have 6/15. And 4/3. I had to multiply 3 by 5, so I'll have 20/15. My original expression then is 2 to the 5/15, x to the 6/15, y to the 20/15, and that'll be 2 to the 5th, x to the 6th, y to the 20th, to the 15th. What's that then? That's the 15th root, 2 to the 5th, x to the 6th, y to the 20th, or if I actually compute 2 to the 5th, I get 32. And that's what we've got.